Good evening, everyone. Welcome all to another webinar session conducted by 99X. My name is Nadisha, and I have 9+ years experience in quality assurance, including different domains. And also, I have 1+ year experience in the big data testing as well. So currently, I'm working as a quality assurance lead in 99X. So let's jump into the today's outline. Today I will be talking about what is big data testing, what are the best practices in building a big data QA strategy, including ETL testing, data masking, model accuracy, and non-functional testing based on the simple case study. Also, I want to talk about some QA challenges in the big data testing as well. The main objective of this today's session is I want to give an understanding about from business perspective how we can evaluate and planning a testing using stats for a big data application. So there are many ways that we can apply these things according to the business logic. In this session, I will not talk about any specific tool, but I will give you an understanding about what are the techniques that you can use into a big data application without worrying any tool. So in future, we will do another session on tools. But for today, after this session, anyone can will be able to do think of how to do a test or building a QA strategy in a simple way using any development language according to the business requirement and the technical knowledge. So first, let's see what is big data testing and why we need it. So in big data systems, big data testing is very critical. So if big data systems are not properly tested, they will have an impact on the company because making it difficult to understand the error, which is cause of the failure and where it occurs. So as a result, finding a solution to the problem becomes challenging. So if big data testing is done effectively, it will eliminate the resource waste in the future. So because of that, it cannot be proceed with using a traditional computer techniques or traditional testing approaches to assure the quality of the system. So in that case, to define a QA strategy, we need to consider the 4 V's of the big data as you can see in this diagram. Every big data testing strategy, we have to consider about functional and non-functional testing. So under the functional testing, first we have to do the data validation. So what is that? It ensures the right data will come from the data sources. So then second one is process validation. In that stage, what we do is we need to make sure that all the processing techniques or exploratory data analysis are applied correctly. Last one is outcome validation. Here we can verify that from the data we get from the processing will output correct data to store in data warehouses without any failure. So then after the development team will develop the application, we can evaluate that using different methods which are applicable to that application. So let's see what are the best practices or techniques in building a big data QA strategy. So ETL testing. So let me explain in a very short what is ETL, since there might be any people to the big data. So ETL means extract, transform, load. As you can see in this picture, extract the data from all different data sources, then transform the data by applying some joining fields or some calculations or removing incorrect data fields likewise, and then load the data into data warehouses. So when it's come to the ETL testing, the integrity of the data must be maintained at every step. So it must be stored clearly and briefly without loss, and should be accessible all the authorized stakeholders. So how can we define a testing strategy to test the data is basically depend on the logical structure of the database, which is modeled according to your business. So throughout this session, my objective is to give you guys an idea as a general, then you can apply those things according to your one. In the QA strategy, first we need to document what is the ETL execution process in your application. You can see the ETL testing life cycle in the second picture, but this would be customized according to our model. So, in a simple way, if I describe that, in our testing strategy, we should include those very clearly how we plan to execute those. For example, how we validate the required data or data sources, or validate source to target mapping. Target sends the data warehouse we store our data. How the this test design and execution will happen. Also, data quality and the performance we need to verify. So as well as validation of the data model. When we are fetching the data from the different data sources, those data comes in a raw format. So we have to first check the tables in the sources. So there I will talk about two important test types that every application needs for testing. So then you can apply that in a way which are matching with your application. So in the testing strategy, we have to first include testing types which are considering in our application. Here first, I would like to talk about data quality testing type. So there, what we normally, so I will tell one of the method that you also can try. This is to validate. We can calculate the impurity data percentage. So we can take the impurity percentage of the unrelated data, redundant data, incorrect data, as well as incomplete or duplicate data from our data sources. So what is actually mean by them? For example, I can say that to develop my model, I only need three inputs. So within that three inputs, I need to check that or verify that is there any unrelated data or incorrect data or incomplete data available in my sources. For an example, say some data rows has duplicate data or some rows had null values. So those are mandatory as input to the development. So like we can do the verifications in practical scenarios. So we have to accept that there might be those kinds of historical data in our data sources. So it means we cannot accept 100% pure data from data sources. From my experience, how we approached is, as I said earlier, we took the percentage of the impurity data. Then we can discuss that with the business team and the development team with those percentages, whether we can proceed or we need to do the data cleansing or the data scrubbing. Also, since we are talking about the historical data, there might be some situations dummy data also available. So as testers, we need to consider that as well. So we need to differentiate the dummy data in the production DBs as well. So then under the metadata testing, also we can do the data type checks. Data type check sense, we have to verify that the mandatory field should have the correct data type. Uh, those should correctly mapped in the target warehouse. So let's say that in a very simple data type, which is date and time. So likewise, we can think according to the application and proceed. Data lengths and index or constraints also we can test. So I hope you guys got some idea on those. Actually, we cannot say that these things you should done exactly what as I explained, but from this you guys can get some idea that how you also can apply these things into your business application. So then, what is data masking? Due to the business requirement, we have to mask some sensitive or private data. Sometimes it is because of the GDPR. This is so important when the data is growing. We need to think about the security of the data. So, data masking is one of the security techniques to secure the data at the time of loading, processing, and projecting, also presenting the data to the stakeholders. So, in the QA strategy, we need to document the verification of the data masking process as well. So, based on the model approach, we need to understand which type of masking we are using. Either it could be persistent masking or dynamic masking. In testing, one way we can do the testing is we need to verify that particular field is masking according to the business logic. But in some cases, we cannot test the masking process technique due to the reason where testing team cannot have a way to do that. But we have to ensure that in the ETL process, masked data should not be revealed to the other parties. Then I will tell you how testing is involved in stratified sampling. Once the dev team is identified what is the best model for the application based on the business requirement, they will start to perform the train set split. So what they do is split the whole data set into two data sets like training and test. So the most common ratio of that split is 80-20 or 75-25. So let's say, for example, we have a data set which has defects of a vehicle against its mileage. So then from that main data set, dev team divided again into data points like you see in this diagram according to the example I have taken. So we don't have to worry about how we can do this split. To explain this, I use this example. So then the data set is more clear with the data points. So from these data points, dev team will start to do the training, uh, uh, split the train set. So hope you guys can be able to get the base idea on this split. By using data points, we can create a class table like that. You can see as defective and non-defective. In machine learning, it is good to have a class balanced data set. But in the industry, we cannot always expect like that. So as QAs, when testing a machine learning model, we should always keep an eye on this and the data train and the test ratio as it is could lead us to making a wrong conclusions about the models. As an example, if our testing set doesn't contain any defective data point, the true positive rate automatically becomes zero. To give you guys an example using the data set, you can see as it is biased towards the non-defective class. It is 332. So we can see that even though this model is accurate, we made completely misleading conclusion due to this issue. So to overcome this and to ensure the same ratio between the classes, the train and the test set, we have to use the stratified sampling technique. So using NumPy package, you can do that easily. Also, to check that, we can write some codes to calculate the data points in the testing set as well. So let's take an example for you to understand this clearly. We can say that after this testing, we have found that unbalanced data set. Then this should be a bug of using the stratified sampling. Then the model is unbiased to the training class. So to bias that, what we can do as testers, we can inform to Dev that do the stratified sampling again and retrain the model. Or we can do the up or down sampling to the testing set so that we can reflect the data set, uh, testing data set like the training set. Basically, testers can do that, but this approach will only apply if there is nothing we can do. So otherwise, it is always recommend better to inform the dev team that to do the stratified sampling again. So then we'll talk about the model accuracy testing. Here I would like to talk about techniques used in an example of vehicle defect prediction model. Assume that as input we are giving the registration number and the mileage of a vehicle to check the defects of the particular vehicle. So this is my case study. So this is very simple one. At the very first step, what I do is I will create a test data set like that. So this format is based on the model that I am using. This can be vary based on the approach that someone could use. So I collect the test data which are the latest and not used to train or develop the system. And by writing some methods using Python, I will create this expected result sheet and all the data I got from the production DB against to the vehicle number and its mileage. Then I use the same format and get the results from the model by inputting the fields to the model. So here we have to automate this process since we cannot do it by manually. Then what we can do is we need to compare the each defect with the expected and the actual for that given vehicle number and its mileage. According to the results, I can mark the results as true positive, true negative, false positive, and false negative. So I will tell you one way that we can do the analyze. When you're when you're looking at this table, you can see how we can decide true positive, false positive based on the logics. For example, if the model is identified a defect as a defect, we can say that it's a true positive. So according to the business logic of this kind of application, identifying a defect as a defect is giving a more value to the business. So based on that, we can give a weight scores to do a better analysis on the outcomes. So for example, for true positives, scores would be 1 and the false positive, it could be minus 20. So we can give according to the model. So then we need to calculate the number of true positives, number of false positives, number of false negatives, and number of true negatives, and put those things into this confusion matrix. Then finally, we can calculate the specificity and sensitivity of any other related matrix. If you are new to the data science, there are some more reference available in the internet regarding the confusion matrix. You can get a very good idea from those. So according to my case study, as I explained early, identified defect as a defect add more value. We can use the true positive rate matrix or sensitivity matrix to get the decision about this model. So based on the application, we can define the relevant metrics. So by discussing with the business team as well, we can decide the values and make sure that our system is working as expected. So as well as using the heat maps also, we can get the better graphical representation of the data to get a decision. Even non-technical people also can get the idea. So then we'll see what is the usage of ROC. Basically, it is good if QA has a really good skills to analyze the threshold by using the ROC. Typically, in this statistical or the machine learning based or a binary classification model, The output is a binary probability score. The class of sample will be determined depending on this probability score. A sample can be either negative or positive. In general, if the output probability is greater than zero point 0.5, we can say that it will be categorized under the positive class. If it is less than zero point 0.5, it will categorized under the negative class. However, as QAs, we should always check the optimal cutoff point which achieves the both business and the technical requirement. So let me give you an example from the case study. The expectation of the developer is always to increase the model accuracy. Model accuracy sense evaluation matrices. But the expectation of the stakeholders is to increase the true positive rate, which means the vehicle defect detection rate. From the developer's point of view, Model 1 is the best model. But from the stakeholders' point of view, Model 3 is the best model. But when we consider the both requirements, Model 2 is the ideal model. So likewise, we can take the decisions. To check this systematically, we can use the receiver operating characteristic curve, which we call as ROC. So basically, what is this is we can visualize the variation of sensitivity and specificity with respect to the cutoff probability. Using that, we can find the best model. There are several Python libraries are available to construct this ROC curve, such as PySpark, NumPy. Likewise, in testing, based on the optimal cutoff value, we can think that at the point system will output a high true positive value. It means we need to check that whether the developer has used that optimal cutoff value on the final model development or not. In a simple way, how can I plot this manually is, for example, I can give the cutoff as 0. It means I assume every point is a defect. So specificity is 1. If I set the cutoff as 1, then the sensitivity is 1. We can change the cutoff value by manually, and then using the specificity and the sensitivity we can plot, so that we can decide what is the optimal cutoff for that model. So according to your application or the business requirement, you can select the threshold by using this graph. For example, if you need the high sensitivity or high true positive rate, you could pick a threshold that minimize the false positive rate. Then we'll see the kernel density plot. When it's come to the big data, data presenting is a key skill that every big data QA should have. Due to the large volume of data, to analyze those data visualization skill is a must. To have out of these presentations, we can use box plot and the kernel density estimation plot. And knowing how to interpret them can be considered as a major skill that you should have when working in the field of big data testing or machine learning. When you have a large number of data, the best way is to observe the distribution of the data is to have this kind of a plot. So in our case study, we can use the number of these graphs to plot and observe the different data distributions, patterns, and outliers. For our analysis, we use Plotty and Seaborn in the Asia Databricks. In those two plots, for x-axis, it represents the random variable, and y-axis, it represents the probability density. So we can apply this distribution wherever we need to see the data distribution is in the stage to show the overall patterns of the responses of the random variable. For example, by looking at these two, according to the defect prediction model, we can say that the data is deviation from the medium. We are going to remove, or we can take the decision that there are something wrong in that model itself. So, as QA or as developers, we should have an understanding where we can apply according to the business. Main thing is we can't take decision by analyzing this data point by data point, since we are working with a large data set. So this should be a way we need to deal with that. So let's move into the functional non-functional testing. You can do the performance testing and security testing as non-functional testing. The purpose of performance testing are not only acknowledging the application performance levels, but to improve the performance of the big data application. Before performance testing, test engineers should fully consider their testing requirements, then design the complete test scenario to consider then the actual situation of the user. Through the test execution and the results analysis, tester can measure the actual performance of the big data application, such as response time, maximum online user data capacity size, and certain maximum processing capacities. So, as well as in the access performance limit, testers can find the conditions which can cause performance problems. Let's say, for an example, some problems can occur this after a long run in a big data application. And for security testing, we should consider the access controls, authorizations, authentications based on the business requirements. And we should clearly define those in our strategy, how we are going to test those things. Uh, we will see what are the common big data QA challenges, and I will explain some. Because there are a number of fully automated testing tools available in the market for big data validation, the tester must require a skill set and pull in big data technologies. Then the other important point is development cycle begins with the smaller data set and progress to the larger data sets. If the application initial runs go as planned, but the result starts to differ, scalability difficulties become outward. So as testers, we need to have good setup to store and process large amount of data given time intervals to meet the performance requirements. And this is very important and challenging. That is, testers need to proactively use data governance or the information management process in the place to ensure that data is clean. So there are many more, but with the time limits, I will move to the other section. Here we comes to the end of this session. So I would like to talk about what are the best practices that we need to consider in big data QA. Testing teams as well as the training process itself must be mature enough to understand and analyze the difficulties. So the communication is more important. The second one is filtering. As a result, testing specialists must go beyond the execution of test cases and working together with others in each iterations. So, such as preparations, integrations, and validation of the data should occur early in the cycle during the creation of work model, so that the test objective should be very clear. With pinpoint accuracy and the minimal impact, in other words, testers must develop into data scientist capabilities of dealing with complex data structures. As testers, we have to keep in mind that to identify the KPIs and set up validation dashboards after a careful analysis of algorithms and computational logics. Avoid using the sampling methods. It may appear a simple and scientific, but it is dangerous. Ensure the correct behavior of the data model by incorporating alerts and analytics with the predefined results data sets. So finally, if you want to save time, automate with suitable tool and technologies. So that is the end of the session. If you have any questions, you can ask now, or even later you can contact me for any clarifications. There is the one question regarding upsampling and downsampling can be done by QA. Yes, QA can do that, but it should be a very rare case. For example, this approach will occur only if we are very close to a release. By changing, sometimes you might be have any questions regarding that. By QA can do these changes and it will affect it to the data set. So by changing the values won't give the negative image because to bias the proportions, that is what we need to do so that there is nothing wrong with that. There is another questions regarding uh, the question is you have mentioned that the KD plot was used to determine the outline, but why we do it really need KDE plot to determine that. Uh, so I will answer that question. So in that case, who will define the cutoff? So that is the question. So when we are working with the data, we get to work with different domains. It can be medical, it can be vehicles, so also it can be a telco likewise. But we are not data domain expert to determine those points. So in that case, so the decisions has to be systematic. In the other words, it should be statistically verified. In that case, we have to use the KDE plot and or the box plot to determine the outliers. So the time is up, guys, and thank you very much for spending your valuable time for this session. So I hope you will be able to get some important facts from this session. So please subscribe our 99x channel to get notifications about more webinars in future. So have a wonderful evening to everyone. See you on the next webinar.